5, and today we're talking about gases, but no, not the type of gases you're thinking about.
Thank you, Diane. So, first of all, what are the properties of a gas?
The properties of a gas are gases have mass, they're easily compressible, gases fill up their containers completely, different gases can move through each other really quickly actually, and gases exert pressure, but the pressure depends on the temperature that the gas is at.
Very interesting.
It is quite fascinating.
Well, the properties of gases can be explained through the kinetic molecular theory, and this states that gases are made up of small particles that move in rapid random motions. These particles do not attract each other, but when they do come in contact, the collision is perfectly elastic.
That is so fascinating.
Yes.
Wow.
Indeed.
I want to go to Friendly's.
What's your favorite flavor?
I like forbidden chocolate.
No, I like forbidden chocolate.
We
both like forbidden chocolate! Buy yours today.
I know I want to go to Friendly's.
Me too. And we're back. Now we are going to be learning about Boyle's Law. Diane?
Yes, Boyle's Law was a law discovered by Robert Boyle. It stated that volume and pressure are inversely proportional to each other.
This means that at a constant temperature, as the pressure increases, the volume decreases, as well as if the pressure decreases, the volume would increase.
Wow, that's so fascinating.
The next law we will be learning about today is Charles's Law. Diane?
Thank you, Denise. Charles's Law was discovered by Jacques Charles. Investigated the relationship between the volume of a gas along with its temperature.
It stated that the volume of a gas is directly proportional to its temperature. So, at a high temperature, the volume of a gas was higher, and at a lower temperature, the volume of a gas was lower. And this can be explained through the equation V1T2 equals V2T1.
Good bread.
To further investigate Charles's Law, we have decided to conduct an experiment that you can try in your very own home as well.
Proper lab goggles. Now we are ready to go. First off, measuring with centimeters, you take the measuring tape, put it all around the balloon, and we get 62 inches.
Centimeters.
Centimeters. Thank you, Denise. Silly me. So this balloon's at room temperature, and now we're going to be putting it in the freezer and measuring it 30 minutes later to see what we get. You can put that one. So this goes in the freezer. Let me just move some of this ice cream. Okay.
While we are waiting to check up on our Charles's Law experiment, we'll be moving on to Avogadro's Law. Diane?
Amedeo Avogadro investigated the relationship between volume of a gas and the number of particles present in that gas.
He found that the number of particles of a gas is directly proportional to the volume of the gas.
We can see this in our two balloons that we have. But first we need to put on proper safety equipment. Balloon A, Denise.
Thank you, Diane.
And balloon B. We see that they are exactly the same size because they are filled with the same amount of air. Avogadro's Law.
To check back up on our Charles's Law experiment. Diane?
Hey Denise, I'm here live at the freezer ready to check up on our results. And here's the balloon. Let's go measure it. Now, significantly smaller, it is 59 centimeters.
Wow, what a difference.
That's a full 3 centimeters off.
And we have to remember to record our data so that if we redo this experiment in the future, we can see if our results have changed at all.
We've learned a lot about the different gas laws today, and all of these come together in the ideal gas law.
The ideal gas law can be explained in the equation PV equals nRT. It is vital to know what each of these stand for.
P stands for pressure.
V stands for volume.
N stands for amount.
R stands for constant.
And temperature stands for the T.
Measured in Kelvin.
Thank you for joining us today as we learn all about gases, and we hope that you tune in next week when we talk about other chemistry topics.
Thank you for tuning in. Diane, I hope you have a blessed evening, as well as all of our viewers.
So too, Denise. Good evening, and you.
You got that? No.
Good evening, and today you are.
So, first of all, what is a gas? A gas can be.
Good evening, and you return. So you're gonna be answering.
I'm recording. So.
Because I was gonna say something you knew what I was thinking about.
Thank you.
Good evening, and you are tuned into News Channel 5.
What is a gas?
Did you just do that again?
And what are the properties of gases? Do you know that?
That's so fascinating. And yes, I do know the properties of gases. Gases have mass, which means put them anywhere and they have a particular weight, which we will show in when can we start?
Now to check back up on our Charles's Law experiment. Diane.
Hey Denise, I'm here live at the freezer and I'm about to check the results. Can we do that over?
What day is it today?
Why? It's Friday.
It's Friday, Friday, gotta get down on Friday. What is a gas?
I guess.
What properties can it be explained through? Perhaps these.
Oh yes, these. Wow. Yes.
What is a gas?
You're not supposed to ask me what it is. Explain what a gas is and explain what a gas does.
When conducting an experiments for safety reasons.
Do you want this balloon to blow up in your eye?
No.
Am I starting this?
Yes. To further investigate Charles's Law. To further invest. That sounded really weird.
And we're back. Oh wait, we've been back. Let's start over.
Okay.
7 a.m. waking up in the morning. Gotta be fresh, gotta go downstairs. Gotta have my bowl, gotta have cereal. Seeing everything, the time is going. Ticking on and on, everybody's rushing. Gotta get down to the bus stop. Gotta catch my bus. I see my